This tutorial will cover downloading the GitHub source code, building the engine solution, and compiling the engine in Visual Studio. First, you'll want to visit the CRYENGINE GitHub repository online. This is public, so you can go ahead, download it straight away. You have the green button here for cloning or downloading. One thing to note is the branches. So CRYENGINE operates under 3 main branches. We call this main, which is our development branch. We have stabilization, which is the branch we use before we release. We go into a stabilization phase to get rid of as many bugs as we can before we release to the public. And release will contain the latest stable release released to the public. So you have 2 options. You either download the source code as a zip form, or you clone the repository using your preferred Git client. For this, we're going to show you how to use the desktop GitHub client. There are numerous advantages to using a Git client, such as versioning and pulling changes, cherry picking commits, which is picking commit, say, from the main branch which isn't in the release branch, to allow bug fix that isn't specifically designed for the release branch but may fix your issue. There are numerous other advantages, but for now we're just going to step right into it. So on the GitHub page, you'll see open in desktop. If you don't have the GitHub client, you'll see this page prompting you to download the GitHub desktop client. So we'll do this now. Once you download the installer, we will want to install. And here you can sign into your GitHub account. Okay, so once you log in to the GitHub client, it will give you an option straight away to create, add a local, or clone a repository. So we're going to clone a repository, the CRYENGINE repository online. You may have noticed on the GitHub website, the CRYENGINE repository clone or download button will give you a link. This link you can copy and paste in the URL section of the clone repository window. Paste it in here. You can choose exactly where you would like to install. We're just going to install it on our default location. And you let the GitHub desktop client do its thing. So this will grab it technically grabs every branch. So it will get the entire repository. You will be able to change branches, say to main or stabilization, from inside the GitHub desktop client. But for now, we're just going to deal with the release branch, as this is the latest stable release. Okay, once the cloning is finished, you'll have the repository opened in the GitHub desktop application, and you'll see we're on the release branch. So to start generating the solution of CRYENGINE, you'll want to run a very specific file that will grab the latest SDKs for you. These SDKs are required for the compilation of the engine. So you'll see this is the physical folder where the repository has been downloaded to. You will want to run the CMake.exe, and this will walk you through the entire process of generating a solution for the engine. Since we have not downloaded the SDKs yet, we will go ahead and download the SDKs. This may take a while depending on your internet connection. So once the SDKs have been downloaded and extracted, they'll be put in the proper location, and you'll get this pop-up window asking you which Visual Studio version or installation you would like to generate the solution for. Since we installed Visual Studio 2017, we would like the 64-bit version, so we'll choose this, generate the solution. You'll then get the CMake GUI, which will give you all the different options of the different components you would like to choose to compile with the engine. For now, we want to keep it simple. We'll use the default options that have already been selected for us. You may notice this already includes the CRYENGINE sandbox editor. When we installed or downloaded the SDKs, there is a very specific SDK that we do not ship. We cannot provide legally. We don't have the license to distribute this SDK. This SDK is required for compiling Sandbox. It is called the Autodesk FBX SDK. You can download it for free and install it easily. We'll show you how. You will see on the documentation, under the technical documentation, under the Getting Started category, you'll have the proprietary third-party SDKs page. On this page we'll list several different SDKs that we use in CRYENGINE. Some may require special licenses that we can't provide ourselves. Some are free. For example, the FBX SDK is not an optional component when you're building Sandbox. It is required. So it gives you the version, the path in the engine source code that it should be installed into, and clicking on the name or the link will take you to the page where you can download this. So using this link should bring us to this page where we can choose exactly which version of the SDK we want to download. Since there's no 2017 version, it's not a big deal to download the 2015 version of this SDK. So we'll go ahead and download this. You'll notice you get an installer. We will accept and click next on the installer. We will choose exactly where we want to install this. As mentioned on the documentation page, it will tell you where this needs to be installed, and we'll install it to this location. The way we access this SDK during compilation isn't the exact structure that it is installed by default. We will need to make a slight change to move the files up one directory. So once the installation is completed, it'll ask you to open the README. We don't need this. We'll close the installer. We'll go back to our physical location for our engine. We'll go to the code SDKs FBX SDK folder. Here you'll notice it has been installed into the 2016.1 folder. So we skip this folder when we're including these files, so we can move these, cut, move up one, and paste. You can delete this folder, it's empty. So now we have the FBX SDK installed, ready for Sandbox to make use of. Now you will have the window with the optional components for the CRYENGINE solution. This is where you get to choose several different components that you may or may not want, such as if you're using WIs, you may want to compile WIs rather than use the pre-built binaries from the launcher, for example, if you want to make changes. Or if you just want the default implementation there available with other changes from the engine. You also have CRYMono for C#, for example, some other components. So you'll see Sandbox has already been selected. On the options for the CMake GUI, we can now configure. This sets all the options that we've selected into the CMake cache, which is used during compilation and generation of the solution. If you still have options in red, you will need to click configure again. This can happen if certain options rely on other options being set. So now everything is fine, there's no red options, no new options. Now we can generate the solution. You'll see the generating is done. This means the Visual Studio project or solution file with projects has been generated, so we can open the project. This will automatically open Visual Studio. You'll notice now that you have all the different components of the engine listed in the Solution Explorer on the right hand side. This is all the different modules of the engine, as well as all the plugins, the sandbox, the different launchers, say for the server and for the game, all the different SDKs that were included, libraries for example, and the sandbox itself. You'll also notice at the end here we have the Game SDK project. The game SDK project is bundled inside the engine solution. This is to make it easier to build and maintain the game SDK project. So in here you can see the game SDK source code itself. One important part of building CRYENGINE yourself is to make sure to select the correct build configuration. At the top of Visual Studio, you may notice the drop-down selection box containing 3 options. You have the debug, profile, and release. Debug has most of the optimizations removed and extra debugging measures inserted to allow easier debugging as a whole. This can cause quite severe performance penalties in some, if not most, cases. Release has every optimization that can be applied. It also removes and locks certain areas of code in the engine, such as CVARs marked with SV cheat and not being able to open assets outside of pack files and some other stuff. Profile is very similar to debug, except that specific optimizations are included that allows the code to run fast while losing a minimal amount of debugging capability. So profile is the recommended configuration. It's also the configuration we use to build and ship the engine via the CRYENGINE launcher. One more important note is you can't mix either of the debug or profile options with any binaries generated using the release configuration. So once you've set the configuration to profile, you can then build the engine. Depending on your machine, this can take anywhere from 40 minutes to 2 hours, maybe more if you have a particularly slower machine. Visual Studio will also use as much power as your PC can provide, which means it may cause other applications to slow or not respond, including the machine itself. This won't cause any crashes, it will just make it very difficult for you to use other applications at the same time. Bear in mind, when you want to test the engine, you have to test the engine with a project. So generally the preferred method is to use a launcher project with the GitHub engine for the version that the launcher has. So if the launcher version of the engine is 5.5.2, you'd like to get the release version from GitHub, 5.5.2, build this, create a project from the launcher for 5.5.2, use the solution generated from this project set to this engine to test this engine. So now that we have compiled our custom engine, we'll need a way to tell our projects to use this specific engine that we've compiled ourselves. We can do this by registering the engine in the project management system. The way to do this is to edit the CRYENGINE.CRYENGINE file and give it a unique name and ID that we can use to select during the switch engine dialog for a project. So first we will navigate to the root folder of our compiled engine. The engine that you downloaded and installed with the GitHub desktop application. In this folder you'll see a file named CRYENGINE.CRYENGINE. This is the metadata file for the project management system. It holds information for the launcher and the project management system itself. This file can be edited by any text editor you like, as long as it's a plain text editor. So you can right click this file and edit with Notepad. In this file we're interested in the first 3 values. This would be the ID, the name, and the version. For our purposes, we're going to add just a GitHub text to the end of each so that we can find it in the drop-down and give it a unique ID so it doesn't clash with any other engines we have registered. So we'll type here GitHub and we'll add GitHub to the name of the engine. So the version that you see here is nothing you need to worry about. You won't see this in the drop down. It won't clash with any other engines. The most important thing is giving the ID a unique string to make sure this doesn't clash with an official engine or any other custom engine you've created. This basically is assigned to the absolute path of your engine. The name is just for your purposes, for finding the engine, say in the drop down list for selecting the engine for the project. So now that we've chosen a unique ID and a unique name, we can save this file, and we can now register the engine by either double clicking or right clicking and choosing register engine. What this does is the project system will assign the path where the engine resides to the identifier that you've put in the CRYENGINE file. Now that we've registered our engine, we can now create a project and assign this project to our newly compiled and registered engine. To do this, we're going to use the launcher. Since we used the release branch on GitHub, this will always contain the latest version of CRYENGINE that's released via the launcher. Then we're going to go to the CRYENGINE launcher. Then we can create a new project. Make sure that we use the latest engine that's available. For this, I'm going to specifically choose a C++ project, although for this purpose there's no need to choose any specific project if we're just testing the engine. I'm going to give it a name. Create the project. Then we'll reveal in Explorer, and this will bring us to the physical folder on disk of this project. And you can see here we have the cry project file. So there's several context options when you right click on the cry project file. The one that we're after is the switch engine version. So we're going to tell this project to use our newly compiled and registered engine instead of the default engine that comes with the launcher. So you left click on switch engine version. Now you can see a pop-up with a list of engines that have been registered. Currently we only have the 5.5 official launcher engine and the custom one that we've registered ourselves. You can see the name that we put in the CRYENGINE file is the name that we see in this dropdown, and this is the engine that we want to choose. So we'll click OK on this. You'll notice that you'll get a couple of warnings. The first warning is asking you to create a backup of your project. This is definitely recommended. Just in case anything was to go wrong, it's always a good idea to keep backups of your project, especially if you have important data there. For now, we're going to skip this backup though. Then you get a warning that the change of the engine can result in incompatibility with your project binary and the engine binaries. For this tutorial, we know that we used the same versions for the launcher and GitHub, so this should not affect us. So now the project should be registered to the custom engine. We can now launch this project via the context menu and go to launch editor, or of course you can double click and this will automatically bring you straight to the editor. What you can also do is set the project to be loaded by Visual Studio. This will allow you to launch the editor with a debugger attached immediately using your project. And this is what we're going to quickly do. So now we'll go to Visual Studio and we will set the startup project to the sandbox project. By default, now when you launch the debugger, it will try to launch the sandbox executable. This is due to it being the output of the sandbox project. But what we want to do is to add a parameter to the launch command to tell Sandbox which project we're loading. So we'll right click on the Sandbox project and we'll edit the properties. On the left hand side you'll see the option for debugging. We go into this option and we'll see we have the command arguments here. So in the debugging options you'll see command and command arguments options. The command option usually specifies an executable or a DLL that's the output of the project. In this case, it's a Visual Studio macro. You can see these macros if you go to the edit, click macros, and you can see the command actually expands to the path of the output executable, which is the sandbox exe in our custom engine. After this, we want to add some parameters. The parameter we want to add is the project parameter. This tells Sandbox which project to load. So we'll go ahead and add -project, then a space, and then the path to the project file of the project we want to launch. It's a good idea to wrap this path with quotes to make sure there's no problems passing the command line parameter if there's spaces in your path name. So once we get the path into the command line argument, we can now apply and hit OK. And now when we launch the sandbox executable via the local Windows debugger, Sandbox will automatically load our project. The first time launching Sandbox may take longer than usual due to it compiling all of the default textures and other resources necessary. Now that we're in the Sandbox, you'll notice that the build number is 0. This is because we built the engine ourselves and we never specified the build number or the version to embed into the output. You'll also notice in Sandbox that the version is 1.0.0. This lets you confirm that you're using the custom version that we built ourselves.